the unit on rationals. It's unit number 7. So for this unit, you're basically, with rationals, you're kind of implying that you're referring to fractions. So the first thing we're going to do for this unit is prepare you to do a project. Next, after that, we're going to simplify, multiply, and divide rationals. Then we're going to look at the graphical characteristics of rationals, adding and subtracting rationals, as well as complex numbers. You're going to have a quiz on those things. And then the last thing we're going to do is to solve rationals, take the review, and then do the Unit 7 test. If you notice, your factoring project for this class is due on the 8th and the 11th of February. Those dates may change, but if you have already started the warm-up, this is a skill from Unit 6, so it's solving radicals. So for radicals, we want to make sure that the radical is by itself. So if I look, this radical is by itself, and the way I get rid of a square root, I'm going to rewrite this problem, is I square both sides of the equation. The way you get rid of a square root is to square both sides of the equation. So squaring both sides allows the square to fall away as well as the radical, and all you're left with is x, and x equals 4 squared, or 16. Here's the answer. Okay? After that, you want to check, does this make sense? Does x equal 16? Question mark. Well, you insert it back into the problem. 16 equals 4, question mark, and 4 equals 4. So there is no extraneous solution, or a solution that doesn't make sense here. Now we check the next one. We have the square root of x minus 5 equals 2, and I just want to highlight the radical here. And if you notice, there is a number that I need to move. I need to move the 5, so I add 5 to both sides. Square root of x comes down. This goes away, equals 7. And in order to get rid of the radical, I need to square both sides. I get x equals 49. Check my solution. Square root of x minus 5 equals 2. So the square root of 49 minus 5 equals 2. And if I check, it's true that 7 minus 5 does equal 2. This checks out, so it's true. Next one, I have the square root of x minus 5 equals 2. I'm going to highlight my radical. Alright, so this entire thing's in the radical, so I'm going to square both sides entirely. And the radical falls away, as well as the power. I get x minus 5 equals 4. Subtract, add 5 on both sides, and x equals 9. Now I'm going to check whether this is true. So the square root of x minus 5 equals 2. Make sure that's correct. Yeah. So square root of 9 minus 5 equals 2. Square root of 4 equals 2. And 2 does equal 2. So it checks out. Okay? And that's essentially your warm-up. Now we're moving on to what your factoring project looks like. So you're going to be simplifying rationals, I think multiplying polynomials, and factoring. So review and factoring. So the first thing we're going to do is to simplify rationals. So a rational comes in the form of f over g, some function over some g function, or f of x over g of x. And the rational function is most recognizable algebraically as a fraction. So while the rational function graphically consists of curves. So basically, um, all rationals, typically what we're implying is that we're working with fractions. Now, when we're simplifying rational integers, we're trying to take out the greatest common factor from the top, the numerator, and the bottom. So here, if I factor out the greatest common factor, that's 9. 27 divided by 9 is 3, and 9 divided by 9 is 1. So simplified, this just equals 3. All right, so we're practicing factoring out the biggest number we can divide out of the top and the bottom. So let's look at 45 and 81. The biggest number I can divide out, I can tell, is 9. It's 9. So 9 over 9 right here. And this is going to cancel. 9 divided by 9 is just 1. Well, 45 divided by 9 is 5. 81 divided by 9 is 9. So simplified form of this is 5 over 9. The simplified form of 45 over 81 is 5 over 9. The next one we're looking at is 4 over 100. So I think I can divide 4 out of the top and the bottom. So that means I'm going to bring out a 4 at the top, a 4 at the bottom. So 4 divided by 4 is 1. 100 divided by 4 is 25. And remember, your simplified version of this is 1 over 25 because 4 divided by 4 is 1. That leaves me with 1 over 25. If you're struggling with that greatest common factor, we can also use the graphing calculator. So you go to math, right arrow over to num, and press those digits. So we go to math, right arrow over to num, and go down to GCD, press 9, second mode, math, right arrow over to num, and I'm going to press 9. So let me try that again. Math, right arrow to num, 9. Now let's look at the two numbers we want the greatest common factor of. We want it for 6 and 9. I already put 3 there, but we want to check. So 6, comma, 9, parentheses, enter, and it's 3. So I'm going to divide out a 3 from the top and a 3 from the bottom. Now with your y's, when variables are the same, you always choose the smallest variable term. So to divide out of the top and the bottom. So let's do our numbers first. 6 divided by 3 is 2. Y cubed divided by y cubed is just 0, so there's no y there. 9 divided by 3 is 3. Y to the 5th minus y cubed is y squared. And there's the simplified version of this fraction. 2 over 3 y squared. So we're working with numbers and we're working with variables. So greatest common factor comes first. So with the numbers, greatest common factor is probably going to be, let's see, I already know what it is, but we'll check. 20 comma 5. Greatest common factor is 5, so I'm dividing out a 5 from the top and a 5 from the bottom. Now your variables, smallest variable, if there are 2, so there's x and x squared, the smaller of the 2 would be x, so I divide out an x on the top and an x on the bottom. Now inside of here, we're going to find what's left by dividing these two things out from the top and the bottom. So 20 divided by 5 is 4. So this is what goes on the numerator or the top. X divided by x just cancels each other out. And then y is what's left. All right. Now on the bottom, 5 divided by 5 is just 1. X squared divided by x is x. So your final answer here, when you simplify this, is 4y divided by x. Next, 15 and 25. My greatest common factor here is 5 on the top and 5 on the bottom. I'm using the smallest variable term. So I have x to the 5th on the top, x squared on the bottom. So I'm going to say x squared on the top and x squared on the bottom to create my greatest common factor. Now inside is going to be my simplified version of this rational. So part by part, 15 divided by 5 is 3. X to the 5th divided by x squared, I'm left with 3. Or cubed, x cubed. X squared divided by x squared just goes away. 25 divided by 5 is 5. So the simplified version is 3x cubed divided by 5. All right, moving on to the next one, 10 and 35. If you're struggling with the greatest common factor, you're going to press math, right arrow over to num, press 9, 10, comma, 35. Enter. And greatest common factor there is 5. So 5 over 5. Now let's work on our variables greatest common factor. I have x cubed and x to the 1, so I'm going to divide an x out on the top and an x on the bottom. Now my y's. Smallest one, I have y squared and y cubed, so I'm going to divide y squared out on the top and y squared out on the bottom. So part by part, I'm going to write the simplified version of this fraction. 10 divided by 5 is 2. X cubed divided by x to the first, so 3 minus 1 is x squared. Y squared divided by y squared just cancels. On the bottom, 35 divided by 5 is 7. X divided by x is 1. Y cubed divided by y squared, you're left with y. Y to the 1. So simplified, I have 2x squared divided by 7y. Next, greatest common factor here of 12 and 10 is going to be 2 over 2 for my numbers. For the letter A, I have a to the 4th, a cubed. I always use the smaller one, so a cubed over a cubed times the simplified version. But we get that by dividing these things out, this greatest common factor out. 12 divided by 2 is 6 on the top. A to the 4th divided by a cubed, so 4 minus 3. I'm left with a to the 1. On the bottom, 10 divided by 2 is 5. The a cubes cancel each other out. Simplified version is 6 over 5 times a, or 6a divided by 5. These are the same things. Last one, simplified version. Divide out my greatest common factor, 3x squared over 3x squared. All right, so you have your negative. I didn't do anything with it. 9 divided by 3 is 3. 6 divided by 3 is 2. Simplified version, this goes away. Negative 3 over 2. So that's that. Okay? Now what about if we're dealing with rationals this way? So what we do is we go part by part. If we're just dividing, if we're simplifying to divide out, we divide each term by the denominator. And you only do this when there's one term in the denominator. So one term on the bottom. So that means I'm going to separate each one and divide each one by 2. Minus 8 divided by 2 equals, this goes away, negative x minus 4. And there's the answer. Next, we have 3x squared divided by 3x plus 16x cubed divided by 3x. Simplifying, 3 divided by 3 is just 1. X squared, you have 2 on top, 1 on the bottom. You take 1 away, you're left with x. Plus 16 over 3 is just 16 over 3. But your x's, you have 3 on top, 1 on the bottom. Take 1 away from the top, and you're left with x squared. And there's a simplified version of this rational. Next, we have 2xy divided by 2x plus 4x divided by 2x's. This simplifies to 2's cancel, the x's cancels, and the y's can't. The y does not cancel, it drops down. 4 divided by 2 is 2. X's cancel. Here's my final answer. Now, with the next set, it's a little bit different. We're looking to see what cancels out. What is the same on the top and what is the same on the bottom? So if I go through, I have x plus 2 on the top and I have x plus 2 on the bottom. So these two cancel each other out. These are the same. This divides itself out. This equals, and they have to be in parentheses. What I'm left with is 2x minus 2. This is how you show your work on your project. If you're not showing this work, it's going to be counted off. So I'm looking for, I have x plus 5 on the bottom, so I'm looking for x plus 5 on the top, and that's what's going to cancel for my rational. And I have to cancel this out, so I mark it out, and I'm left with 3x minus 5. For the next one, I'm not going to highlight it any longer. I look for x plus 5 on the top. I don't see it. I do look for x minus 5 on top, and I see that. So what I'm left with is a 1 on top. 1 over x plus 5 on the bottom, and that just equals 1 over x plus 5. Okay? That's the simplified version. You can't move any farther than that. Now, adding and subtracting rationals with like denominators. So these are like denominators. The numbers on the bottom are the same. So what I'm going to do, I'm showing my work. This is a part of your project. If you're not showing the work, I'm going to mark it wrong. So 1 plus 3 over 2 simplified equals 1 plus 3 is 4 over 2. This equals 2. And I circle my answer. The next one, this equals 4 minus 5 on the top, and the 2's are the same, so I write 2. This equals negative 1 over 2. For the third one, this equals 6 plus 9 in the numerator, 7 on the bottom. This equals 15 over 7. Next one, 1 plus 3 on the top, x on the bottom. This equals 4 over x. Final answer. Next one, we have x squared as the denominator. So x minus 3, I can't combine those terms, so that's my final answer. Next one, I have x minus 1 in the denominator, so I'm going to have x minus 1 on the bottom, 1 minus 15 on the top. This equals a negative 14 over x minus 1. Final answer. Adding and subtracting rationals create lowest common multiple. So we're looking for the lowest common multiple for 3 and 2. So for this one, what we're trying to do is to get the denominators to be the same. So what we're going to do first is to go to math, right arrow over to num, and we're looking for LCM, that's number 8. And we're going to say 2, comma, 3, close parentheses, enter. Lowest common multiple here is 6. So you can also get it by multiplying these two. So we're going to do a little bit of the opposite here. So we're finding lowest common multiple. So multiply denominators. Okay? So what we do, we have our, what's going to happen is you're going to multiply this number, these numbers, on the opposing fraction. So that means for 3, you're going to see me multiplying a fraction of 3 on the opposing rational. For 2, you're going to see me multiply a fraction of 2 on the opposing radical. And you'll see what I mean here. So for my first rational, I have 1 over 3. So to get those denominators to be the same, I'm going to have to multiply 2 over 2 here. So times 2 over 2 plus, for my second rational, I have 3 over 2 times 3 over 3. This equals 1 times 2 is 2 over 6 plus 3 times 3 is 9 over 6. Put these together, have 2 plus 9 over 6 equals 11 over 6. So we're going to do that again. So we know the denominator at the bottom for number 2, I have 5 and 3. So I'm going to have 5 swing over here and 3 swing over there. So this equals 4 over 5 times 3 over 3 minus 1 over 3 times 5 over 5. This equals 12 over 15 minus 5 over 15. I put those together. 12 minus 5 over 15 equals 7 over 15. Next one, we have 2 over 7 times 4 over 4 plus 3 over 4 times, you guessed it, 7 over 7. This equals 8 over 28 plus 21 over 28. This equals 29 over 28. That's my final answer. Next one I have is 1 over x plus 3 over 2. This equals 1 over x times 2 over 2 plus 3 over 2 times x over x. This equals 2 over 2x plus 3x over 2x. Simplified, I have 2 plus 3x over 2x. Next one, 1 over x squared minus 3 over 2. So 1 divided by x squared times 2 over 2 minus 3 divided by 2 times x squared divided by x squared. Simplified, I have 1 times 2 is 2 over 2x squared minus 3x squared. That's my final answer. Next one on this type of problem, my denominators are x and x minus 1. So for 1 over x, I'm multiplying x minus 1 on the top and then x minus 1 on the bottom. For negative 1 over x minus 1, I'm multiplying x on the top and x on the bottom. Simplified, I have 1 times x minus 1, I have x minus 1. On the bottom, x times x is x squared. X times negative 1 is negative x. Over here on the right, so minus 1 times x on the top is just x. On the bottom, x times x is x squared. Negative 1 times x is negative x. You can see your denominators are the same, so we just combine x minus 1 minus x on the top divided by x squared minus x. X minus x just cancels, equals negative 1 over x squared minus x. Multiplying polynomials, I'm going to use this distribution. If it helps to rewrite it, you can write 2 times x minus 2. If that helps, I don't know. But regardless, when you distribute, you just draw your arrows to what you're distributing to parentheses x. If you're not showing your work on this problems, I'm going to mark it wrong. 2 times negative 2, 2 times negative 2, make sure that's positive 2, equals 2x minus 4. Here is the final answer. Okay, for the next one, I have 2 different numbers in the front. So what I'm going to do is x times the second quantity, so x times x minus 4. And then for my second term, plus 3 times x minus 4. Going to distribute. Again, x times x is x times x, and then x times negative 4. So plus x times negative 4. I keep going. 3 plus 3 times x plus 3 times negative 4. Simplified, I get x squared minus 4x plus 3x minus 12, combined like terms, x squared minus 1x minus 12. And if you notice, you started off with the factors for this particular polynomial. In the next step, this is a more simplified version, so we have a times the second expression, so a times c plus d plus b times c plus d, so b times the quantity of c plus d. Then you have to distribute again. A times c is just a c. A times d is a d. B times c plus bc, and b times d is positive bd. And if you'll notice, there are no like terms here, because you're working with all variables. So that's the end of this section. The next section is going to be factoring, just a review of factoring. Please go back and look over simplifying rationals, multiplying polynomials. You are expected to show all of your work. Not showing your work and just writing the correct answer only guarantees you part of the problem being correct. So I will be grading this accordingly. Good luck. I hope that you follow directions, look at the steps, go back and look at the video. Have a great day. Please check the other video for factoring. It's a skill that's very necessary for this unit. Have a great day.